Today we are going to discuss the topic of design patterns. So, if you are new in the industry, you are going to hear this name quite a lot of times from now on. And if you are already an existing member, existing person in the industry, then you might have heard of this name multiple times. So, what are design patterns? So, we'll begin with design patterns introduction. So, design patterns are basically they are well tried, tested, and proven solutions for common design problems. Obviously, so when we enter into a field, so there can be multiple problems that can be there. Okay, so that needs to be solved. So, in other words, design patterns are solution approaches and ideologies to some standard problems faced by most programmers, which were worth documenting officially. An important point to be noted is design patterns represent the ideologies to solve some standard problems. They are not the actual implementation, they represent the ideologies. Basically mean to say is the way of thinking. They are also language independent. So they do not depend on the language. So like what kind of problems are we talking about here? So let's say one of the problem, let's say you have a website. You have built a website in let's say your company. So let's say its name is maybe buyit.com. Buyit.com. Okay. Yeah. So let's say there are in buyit.com, obviously by the name it suggests that it's an e-commerce website. So there are three buttons, let's say, on the top. One of them is for let's say orders, my orders, and another one is maybe for cart. Basically, what all things that we have put in the cart, we can buy them now or in later stage. And another one, let's say wallet. So So this is what we see when I am a customer to the website. I am a client to the website. Okay. But what goes behind the back? So let's say this order, this obviously when we click on this order, the request goes to the backend. So where it goes in the backend? So in the back, obviously backend is not some physical space. It's actually a virtual space. So it goes into a that request is basically let's forget the what goes on in the middle. So that request goes to a order service. There is some order service that we will be talking about. Order service. Okay. Order service or order controller, if we can say. Okay. There might be one of them. One of the service may be card service. Okay. Another service might be wallet service. Okay. So when the request comes here, so this is attached with this is mapped with this, and this one is mapped with this, and this wallet is mapped with wallet service. Okay. So when the request goes there, so obviously when we talk about orders, so obviously there cannot be order cannot stand independently. It needs a user, right? A user has some orders, है ना? User has some orders, right? User has some items in his cart. User has a cart, and user has a wallet, some money in his wallet, and these kind of things. Okay, so they cannot matlab, stand. They cannot be defined without a user. Okay, so everyone needs. So each of these services need user to get operated on to handle the request. So whenever a request comes for the orders, let's say to fetch the orders, so the next question that comes to the mind is comes to mind of the programmer that like for which user should I find out the orders, right? So we need a user here also. For which user should I fetch the cart items? For which user should I fetch the wallet wallet balance? Okay. So basically, this user data needs to be fetched in each of the services. So where will our data be? Obviously, our data will be somewhere in our database. Obviously, uh, some common database which is being used by this service, and this service as well. Okay, so they are using this database. Okay, let's say this database only has user data only. Let's say, for instance. We could have also mentioned it as a table. So these all services need to fetch user data from user table. Okay. Now, should we be creating? Obviously, this whole complete is coming in some backend of the buy.com website, right? So obviously, this whole is a complete application, है ना? This backend. So we do not need three different instances of the user table connection or the user DB connection. We need a single connection. Why do we need to create three connections to the same DB when we are working in the same environment? So this was one of the problem. Like if we, well, there was one way in which we have to create independent connections for each of the services. Another way is we create a single, uh, we create a single instance for each of the services, and we leverage that single instance for all of them, right? Okay, so that's where this kind of problem is handled by singleton pattern. Okay, so right now with this which I have made now, this structure or this architecture of some uh, yeah. So I meant to say that there are three different classes for, let's say, order service, class, card service, and wallet service. You could have designed completely independent services as well, which can find out their own users. Okay, let's move on. So, okay, then the next thing comes is reason behind the popularity of design patterns and why should we study them. So obviously, so there can be like the problem that we discussed right now. So it was a common problem. It can be faced. It will be faced by most of them, most of the programmers, right? Mostly all, most of the programmers have already felt this problem, have already faced this problem, and the programmers which are currently in the present world and in the coming world also, coming times, they'll also be facing the same problem. Obviously, one way or the other, they can be facing this same problem in their own respective use cases. Okay. So what they have done is, when we study the design patterns, we get the solutions of the experienced programmers. Some programmers who face these problems, they have created their own solutions to these problems. Basically, that does not mean the exact solution. They have defined a solution ideology, like how to think. Okay, like singleton pattern is a way to think to create a solution. It can be implemented in any of the language, in C++, in Java. Obviously, the implementations will be different, but right. But the core ideology will be the same. Okay, so that's what it is written here. The name design patterns also do suggest that they are patterns found and needed during the design when we are designing a system to solve already faced problems by other programmers and designers. Say, for example, if you are working to create the design of an application, and if you face some challenges in solving a particular problem or use case in the code, and that challenge is similar to some already solved pattern of the problems, then you can actually save time and refer the design ideology which is already proven and followed to solve that pattern of problems, which is already obviously proven by some experienced developers. They have officially documented it so that everyone can learn from their experience what they have created. So these design pattern ideologies have been created by experienced and expert developers. Okay. Example, if you need to deal with the data from a database table in the methods of 10 different classes. So this example we already discussed. We can skip it right now. Okay. So now, yeah. So one more thing that I want to discuss about design patterns is what are the pros and cons of design patterns. So why should we basically, one more point that I need to discuss, and why should we study design patterns? So design patterns is basically, it's a common ideology also among your peers, among your colleagues. When you are in a company, when you are in a company, then multiple colleagues talk to each other, right? about their solutions to some problems they are facing, or some architecture they are building for a new service that the company is going to implement or their team is going to uh, implement, right? So when they discuss the ideas also, like what I am working on, how I am going to proceed. So in order to do that, so what they can do is they can, so if they have some common ideologies, uh, which they can tell using a single name, so the person with whom they are discussing, their colleague, will easily be able to understand it, because both of them have studied the same principles, same design patterns, right? So design patterns are a common way to for communication as well, and to grow up on that already existing knowledge from there. Like like this person said that I have used, let's say, builder pattern in my code, है ना? Builder pattern I've used in my code, or state design pattern I've used, right? So this person will also get it, correct? Because he also has studied, so instantly in his mind he'll get. So that's why we had to name these design patterns. Okay. Next thing comes in this topic is the classification of design patterns. So obviously there will not be a single problem in this case. There might be a lot of problems. We can assume it to be infinite as well. That would also not be a bad idea. Okay. But uh, most of the problems which have been documented till date by four authors, four programmers, or we can say scientists. So they documented in a book called Design Patterns. Okay, you can search for this book. The name of we call those four scientists a gang of four. They are famous by this name, gang of four. Okay, so gang of four at their time, I guess in 1995, they documented 23 design patterns which they noticed and for which they designed their solutions, for which they found the solution. So they documented those 23 design patterns at that point of time. Okay. So those 23 design patterns are not lying individually. They are also subcategorized. They are also in different categories. So these 23 design patterns are divided into three different categories. First one is they analyze the patterns, like how should they divide them, these patterns into categories. So one of them is creational design patterns. Another one is structural design patterns. The third one is behavioral design patterns. So these are the three categories in which this gang of four scientists or authors, they have divided the design patterns. Okay, so let's study briefly about each of them. So creational design patterns revolve around the ideology of the ways of classes and objects creation. Let's say, obviously, when we are building some application, the back end of some application or the front end or whatever, right? So we need to, we feel the need to create classes and objects. No? So these creational design patterns, their ideology revolves around this particular scenario or the use case, right? Where we have to create classes and objects. Okay. They leverage the mechanisms of inheritance and delegation in order to create classes and objects. Okay. I'll tell you one thing. So how do we create class objects? Let's say. So we create objects using the new keyword, right? So, but there can be multiple classes, right? In our backend, obviously. There can be 50, 100, maybe 5,000, depending on the uh, complexity of your application, what work it's doing, what use case it is solving. So, right, there can be numerous classes. Okay. So in those classes, obviously, we feel the need to create, according to our use cases, we need to create lot of objects. So this kind of becomes messy when we directly create the objects now using the new keyword in each of the classes, and also the uh, also some of the objects that we create should be created only once, like we discussed in the singleton pattern previously, that we do not want different instances of a DB connection. We want the same instance of the connection to be used in all the classes, right? So these kind of things where we have to create new objects, these kind of problems or the patterns that were found. So these are the patterns which are related to them are defined in creational are comes under the category of creational design patterns. Okay. So how many design patterns are there under creational design patterns? So there are five design patterns under this category. Like one of them is builder pattern. Another one is singleton pattern, prototype pattern, factory method pattern, abstract factory pattern. Okay. So we'll study each of them one by one in the upcoming videos. So the next category that comes is structural design patterns. So what are structural design patterns? So as the name also suggests, they structural design patterns are concerned with the simplification of highly complicated systems by analyzing the relationships between the objects in order to compose the existing objects into larger structures so as to make the design loosely coupled and robust. So what does this mean? What's this statement mean? I'll tell you. Let's say, so in your code, you might be using uh, uh, different classes and objects, right? So among those classes and objects, there might be there might be a lot of complexity that might be going in your code. For example, let's say you have a service. Let's say uh, you are creating images. You convert images from let's say you take 480p images and you convert them to uh, you compress them basically. You or 480p images of size, let's say you take images of size, let's say greater than 10 MB, and you convert them to compressed images, है ना? Okay. Let's say you have defined your threshold, like you will be converting the images to less than 2 MB. Okay, after compression. Okay. So, and you what you do is you store those images onto your some cloud or somewhere so that they can be utilized further also. Let's say you might have used Google Drive or है ना, Google Drive kind of things which work on the Google Cloud, right? So whatever you do, whatever you put on the Google Cloud, what it does is it stores in its own database somewhere which is lying somewhere in America or in somewhere around the globe, right? Okay. So there can be another use case also, like we want to push that data onto two different servers. One of them is, let's say, uh, Google server, है ना? Google server. Another one is, let's say, AWS. Okay. So So I need to push this data, push this file onto two different servers, right? So I can maybe, since I have to, uh, matlab, I have to decide at that runtime, like where my request, whatever my request has come, like do I have to send it on the Google server, on the AWS server? So I can use a proxy service here, है ना? So these kind of patterns which we find out, like obviously there are right now there are two servers that we are dealing with. There can be multiple other locations where we want to send our data. Maybe let's say we want to send our data in a local server as well, है ना? Let's say we also want to send the data in uh, in a cache as well, है ना? So these kind of things where we want to send the data into a multiple things, or we want to dynamically decide what to do next. So there kind of this similar situation can be handled by proxy design patterns, right? So this kind of problems are dealt in. This kind of problems or patterns are dealt in structural design patterns. So there are 7 design patterns in this under this category. So one of them is adapter pattern, another one is bridge pattern, composite pattern, decorator pattern, facade pattern, flyweight pattern, and proxy pattern. Okay. Yeah. So and whatever. So basically, what we do here is one more thing that I would like to point out is we find out the relationships among the objects, like where we have to obviously this could have been done using different if else conditions, and we would have used the objects to push the data into different locations using different objects. So what we did is we identified the relationship among those objects, and we managed those relationships in such a way, we managed the structures which are somehow implementing those relationships or somehow coordinating between those relationships in such a way that they have created a larger structure, which is an organized structure. है ना? So we have composed all these uh, smaller objects into a bigger, to create a bigger composite object, which deals with pushing the data. So that pushing the data where we want to push, that can be decided using a flag or something. But we have organized the whole sector. Instead of using a lot of if and else conditions at different places, we have organized it and we have given it a single gateway. So these kind of things are dealt in structural design patterns, where we compose the existing objects into larger structures. Okay, so as to make the design loosely coupled and robust. Loosely coupled means there are not a lot of dependencies among different, there is no biasness in the code. There is no bias in the code. So if we want to, let's say for tomorrow, let's say if we want to switch, let's say for tomorrow, Google server ceases to exist, and let's say some new server, XYZ server comes in the market. So we want to update Google server by, we want to remove Google server and we want to start sending the data to XYZ server. So that process of adding that XYZ server in this particular scenario, fitting that XYZ server in this particular scenario should be done easily. We should not take it should not take lot of efforts, right? This means this is this is basically the ideology of loose coupling. Okay, so we have to design a system in such a way that the system is loosely coupled. Okay. Next, the next design pattern that comes is behavioral design patterns. So behavioral design patterns are concerned with the object's creation among themselves and with the user. Uh, I'll repeat it. Behavioral design patterns are concerned with the object's interactions among themselves, like the way the objects interact among themselves, and also with the user, how they are interacting with the among their fellow objects, and also with the user. So this behavioral design pattern is concerned with those interactions, है ना, with the user based on the distribution of responsibilities among them. Like obviously, different objects will be having different responsibilities. So how these different objects interact with each other, which are having different responsibilities. So this behavioral design pattern is concerned with that particular one. Basically, we can say that it is concerned with their behavior, how they are behaving with each other. Okay, the ultimate goal of this pattern is to make sure that the communication between the objects become smooth, simultaneously maintaining the fact that the design has loose coupling. So the ultimate goal is that communication between those objects and with the user should be smooth. It should not be too complex, you know? And it should not be too much costly as well. So we have to do that by maintaining the fact that the design is loose coupling. So loose coupling is a bigger goal. We should always somehow be following that. Okay. So the design patterns that fall in this under this category are yeah, chain of first of all, I'll give you one example. Let's say uh, let's say you have ordered a package from, let's say, buyit.com only. Okay, let's say you have ordered a package, or you have ordered some jeans, है ना, from buyit.com. Okay, so what will be the states of when the day, let's say, you bought that particular thing, you were seeing that particular thing on the website of buyit.com at, let's say, 31st July only, let's say today, है ना? So what all stages will be there? So firstly you are looking. Then we are not initiated any process of the buying. Okay. Then we if we get interested in that, what we do is we put that in. Maybe we can put that in cart, or we can go and buy directly. Then our order initiates when we start filling the order details, like how many quantities of it we want to buy, now how many particular pieces of the jeans we want to buy. So then we initialize that order. Okay. And then after initializing, what we do is we do the maybe we select the payment procedure and all those things. So after initializing and after initialization, uh, we fill order details, fill and order. Okay. So this is ordered state. Then what we are doing is, after ordering, where our order goes is, our order goes for delivery, है ना? For in transit and these kind of things you might have seen on the website, like order in transit or in process. Like your order is being processed first. Okay. Then after that, what happens is your order is in delivery mode. Once your order confirmed, maybe order confirmed is one state. Order is confirmed, like they have checked like when can this end, or is that particular piece available, or is those many number of pieces available, or whatever things they have to do, whatever formalities. So order confirmed state they have, yeah, we have reached. So after order confirmed state, we have delivery state, right? Delivery phase, in delivery we can say, है ना? Then after that, the final state is delivered, when you have got the order. This is the final state, delivered state. So this particular scenario where we are changing, these are all states. This is initialized state, initial state, है ना? This is ordered state. These are all states. So this particular scenario of handling different states, where whenever one state completes, so what it does is it marks itself, it changes the state of the order to fill and order state, है ना? To the next state. When the work of this particular state is done, then it marks or delegates the product to the next state. So this particular scenario or the use case is handled using the, you can find out certain solutions using the in the state design pattern. Okay. So these kind of design patterns which deal with the behavior and the responsibilities of the objects and the interactions between them. So these are dealt with in the under the category of behavioral design patterns. So there are 12 design patterns under this category. So one of them is chain of responsibility pattern. Another one is command pattern, interpreter pattern, iterator pattern, mediator pattern, memento pattern, observer pattern, state pattern. We already discussed visitor pattern, null object pattern, strategy pattern, template pattern. So these are all 12 kinds of 12 different patterns under this category. So yeah, so we have seen, like, there are, if you will count now, so 12 plus 7 plus 5, there are approximately 23. So there can be more as well, but if you will notice, uh, I'll ask you a question as well. So can uh, matlab, will always be there 23 patterns only, or can they be increased? Obviously, they can be increased. We face different problems every day, so we can create our own design patterns as well. But in order to standardize them, we'll have to for we'll have to uh, matlab, get certified, or we have to I also do not know exactly where we can get our design patterns, our own solutions to some new problems that we have faced. How can we standardize them? I do not know the procedure, but they can be done. Obviously, that's not the end. Like 23 design patterns, not after that. So there are more than 23 design patterns. If you will study on the internet, there are more than 23 design patterns. So one of the another other category is J2EE patterns. There are some patterns. There is one pattern under this category. One of them, that is MBC pattern. So obviously, this list can be grown. Okay. So right now till this so this 23 design patterns that we talked about, this was documented by the gang of four that we discussed, right? Okay. And for the next things, for every design pattern we'll discuss in the upcoming videos. Okay, till then, take care. Bye bye.